Hello everyone. Today we are going to discuss about axioms and properties of probability. Let us start with axioms of probability. What is an axiom? It is a rule or principle that most people believe to be true. Why we need an axiom? Given an experiment E and a sample space S, the objective of probability is to assign a number to each event. The number will give a precise measure of chance the event will occur. To ensure that the probability assignments will be consistent, all assignments should satisfy the three important axioms of probability. These are the three axioms of probability that make up all the theorem in probability. So let us start with axiom 1. For any event A, P of A greater than or equal to 0. This means that the chance of occurring any event is non-negative. We can also say the minimum probability is equal to 0. This is true, right? We can say there is 0% chance of any event happen. But we cannot say there is negative 5% of chance that there is a event will happen. Coming to axiom 2. Probability of the sample space S is P of S, which is equal to 1. This means the sample space S contains all possible outcomes of experiment. That is, the outcome of each trial always belongs to S. If something happens, the outcome should be within the sample space. From this axiom, we can say the maximum probability is equal to 1. From the axiom 1 and axiom 2, we can understand that the probability of any event will be 0 to 1. Coming to axiom 3. If A1, A2, A3 are disjoint events, then P of A1 union A2 union A3 is equal to P of A1 plus P of A2 plus P of A3 plus dot dot dot. This union, this union notation in probability we can read P of A union B is equal to P of A or B. So here we can say probability of A1 or A2 or A3 dot 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 equal to probability of A1 plus probability of A2 plus probability of A3 dot dot dot. The probability at least one of a number of events will occur and no two events occur simultaneously. The chance of at least one event occur is equal to sum of chances of individual events. That is probability of A1 or A2 or A3, any one event is equal to sum of chances of all the individual events. This is the axiom 3. So in summary, if A1 and A2 are disjoint events, then P of A1 union A2 equal to P of A1 plus P of A2. We can say P of A1 or A2, right? The same is true when we have n disjoint events, that is A1 to AN. Then P of A1 union A2 union A3 dot 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 up to AN equal to P of A1 plus P of A2 plus P of A3 dot 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 up to P of AN. So the third axiom states true even for a countably infinite number of disjoint events. And this notation we have already discussed. See, this is event A, this is event B, and this diagram shows the A intersection B, and this diagram shows A union B. So we can say A and B. Instead of intersection, we can say A and B or A comma B. P of A intersection B, we can say P of A and B or P of A comma B. Similarly, P of A union B, we can say P of A or P of B. See, here A and B are disjoint even. So there is no intersection. A intersection B is equal to null set. Then P of A union B equal to P of A plus P of B. because P of A intersection B is equal to null set here. So these are the understandings from axioms. Let us start derive the properties of probability using these axioms. So first complement rule, which says for any event A, P of A bar equal to 1 minus P of A. This A bar is complement of A. What is the complement of an event? All outcomes that are not in the event are called complement of an event. See, this is a sample space. A is an event. What are all in not A is A complement. What is not A is A complement. So if P of A equal to probability of A, then we can say P of A dash or P of A bar or P of A complement is equal to probability of complement A. So let us prove this rule. P of A bar equal to 1 minus P of A. We start with what we know. So S is a sample space which is equal to A union A complement. And A intersection A complement. This is not B, I'm sorry. This is A complement. A intersection A complement is equal to null set because A and A complement are two disjoint sets. By axiom 3, P of A union A complement is equal to, we can call it as A naught. P of A union A naught equal to P of A plus P of A naught, which is obviously equal to P of S. So now we know that P of sample space equal to P of A plus P of A complement. And by axiom 2, we know that P of S equal to 1. So from these two equations, we can get 1 equal to P of A plus P of A complement. And by simple algebra, we can get P of A complement equal to 1 minus P of A. And also we get an expression P of A plus P of A complement is equal to 1. Here A and A complement are disjoint events. Why this complement is useful? Let us understand this using an example. When throwing two dice, what is the probability of two scores are different? Like the outcome of two dice with different scores are like 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 and so on. That is first die scores 1 and second die scores 2. First die scores 1, second die scores 3 and up to first die scores 1, second die scores 6. And again first die scores 2, second die scores 1, first die scores 2, second die scores 2. 2 comma 2 will not come because we want different score. So except 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 and 6 comma 6, it is a long list of outcome of two dice with different scores. So to get a outcome of two dice with different scores, as it becomes a long list, we are going to get the complement because the complement of A where two scores are same is having only 6 outcomes. Here A complement equal to 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. So now it is easy to calculate P of A complement first, then calculate P of A using 1 minus P of A complement. This is where the complement is very useful. So now P of A complement is equal to 6 by 36. In A complement we are having 6 pairs 1, 2, 3, 4, 5, 6 and I will explain you how this 36 comes. The outcome of one dice is 6 and as we are throwing two dice 6 by 6 equal to 36. So this is how the 36 comes. So 6 by 36 equal to 1 by 6. So P of A complement equal to 1 by 6 we arrived. And now from the complement rule we can get P of A equal to 1 minus 1 by 6 which is equal to 5 by 6. Hope you understand this concept of complement. Then comes additive rule. P of A union B equal to P of A intersection B complement plus P of B. I will explain this rule using the picture. See here, A and B are two events in the sample space. So the shaded portion is A intersection B naught. That is the portion of A where B is not coming. Or we can say portion of A that is outside of B. And the white portion is P of B. So P of A union B equal to this P of A intersection B naught plus P of B. So from this additive rule, we can understand P of B equal to P of A intersection B, that is this common portion P of A intersection B plus P of B intersection A naught, that is the portion of B not in A. So that is what P of B intersection A naught. P of B not in A plus P of A intersection B both combines to P of B. And P of A union B equal to P of A, that is the complete A, plus P of B not in A, that is this portion. P of B which is not in A. P of A union B equal to P of A plus P of B not in A. The next rule is P of A union B equal to P of A plus P of B minus P of A intersection B. So this A union B can be decomposed into two disjoint events, that is A and B intersection A complement or A naught. So from the additive rule, we know that A union B equal to A plus B intersection A naught, that is this portion. This portion is B intersection A naught, that is portion of B not in A. And we know that P of B equal to P of A intersection B plus P of B intersection A naught. And P of A union B equal to P of A plus P of B intersection A naught. This A naught and A complement both are same. So from these two equations we get that P of A plus P of B minus P of A intersection B. How this P of B minus P of A intersection B comes? We are replacing this P of B intersection A complement with this equation. Using some simple algebra, this can be written as P of B intersection A complement equal to P of B minus P of A intersection B. So we are replacing this for P of B intersection A complement. And now P of A plus P of B minus P of A intersection B is equal to P of A union B. I can also explain using this diagram. See, in P of A union B equal to P of A plus P of B, this completely shaded portion, that is the gray color shaded portion, counted twice. So we have to deduct P of A intersection B, this common portion. Then P of A union B equal to P of A plus P of B minus P of A intersection B. The next property is P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. We already know that when when considering A and C, we added this A intersection C twice. That is why we are deducting this P of A intersection C. And again, when considering C and B, we have added twice this B intersection C. That is why we have deducted one P of B intersection C. Similarly, this A intersection B also deducted because we have added twice. But why this P of A intersection B intersection C is added again? Because the shaded portion, the central shaded portion, added 3 times and subtracted 3 times. So in P of A, P of B, P of C, we have added the central portion also 3 times. And by deducting this A intersection B, A intersection C, B intersection C, we have again subtracted 3 times. So this becomes a left out portion, and we have added that as P of A intersection B intersection C. So this is how this rule comes, and we can extend this rule to A comma B comma C comma D and so on. Here, what happens when this A, B, C are disjoint events? If A, B, C becomes disjoint events, then A intersection B, A intersection C, and B intersection C, also A intersection B intersection C are null sets. But the formula of P of A union B union C still valid. How? Because this P of A intersection B, P of A intersection C, and P of B intersection C, and A intersection B intersection C becomes null event. So that is how the formula still valid for disjoint events also. So that is all about this video. In next video, we will discuss more on probability. So please subscribe my channel and click the bell icon. If you like the content, please hit the like button and share with your friends. Thank you.